Thank you. So thanks everyone for coming. I'm going to talk about some, I will call it bridging the gap between natural language processing and some social dynamics. And the case study will be American politics, but you could take it to different other domains. This work was done in my Northeastern hat with David Lazar and Dan Kalachi. Dan is an undergrad, will probably be looking for grad school, and he's good. So if he applies here, so I highly recommend him. And now for the talk. So I'm going to over-motivate my talk a bit because I think that giving a wider context will make the results that are interesting even more interesting. And in order to do that, I'm going to tell you where I'm coming from and where I'm trying to get to. And then this work and the results that I will describe is like few little steps on the way. So my PhD was mainly on natural language processing, and here are some main works or challenges about natural language processing. So sentiment analysis is one of them. Sentiment analysis is basically assigning some sentiment score or emotion to text. So it could be a restaurant review, and I want to say, okay, is it a bad review or positive or negative review? And it could be much subtler, like it could be about sarcasm in reviews, and it could be like about other emotions, like I'm bored, I'm happy, I'm sad, I'm scared, etc. This is, I would not call it a solved problem because there are a lot of work going on, but we managed to do pretty good on the like 80-20. And on the 20% to get like final improvements, like people use the state of the art is deep learning, and it works for some domain in some settings. It's still a hard problem, a hard task. Does any of you recognize this NLP problem? Okay, so this is machine translation, and this is basically, it's a story about the first machine translation system that was introduced during the Cold War, and we say, okay, how are we going to evaluate the system? So we're going to put an English sentence, we're going to translate it to Russian, we're going to translate it back. If we get sort of the same sentence, it means that we're doing okay. So, by the way, the problem about like how exactly are we going to evaluate things is key issue here in all this stuff, because when you talk about social dynamics, some things are subtle. So it's not always clear how to evaluate in the regular like test set, train set setting. Okay, so they took this verse from the New Testimony. The spirit is willing, but the flesh is weak. Translate to Russian, translated back, and this is what they got. So, by the way, this never happened. This is like an urban myth that everyone quotes about machine translation, and I'm a bit obsessive about this type of stuff. And I checked. This was given as an example why it will never work. Now, if you use Google Translate, you know that it works like reasonably well. Okay, depending on what languages, but it works reasonably well.
The website did that with English and Japanese.
Oh, yeah, okay. Yeah, okay. So here is another example, which is a bit more abstract. I saw her duck with a telescope. So this is a takeoff of Lillian Leon, famous sentence, I saw him with a man with a telescope. And the question is about parsing. Like, how do you interpret this specific sentence? Like, did I have a telescope and I saw someone? Or did I see, with my bare eyes, I saw someone with a telescope? So you would think that if you put the duck here instead, so things are easier, right? Because ducks do not go around with telescope. But now duck could be a verb. So again, it introduced more complexity to or more probable options, which makes it harder to interpret. So these are three of the main tasks that people in NLP are doing today, and the problem, or not the problem, but one, I would say, characteristic of these tasks, they're only in the sentence document level and in the individual speaker level. And when I say sentence document, it doesn't mean that I don't use a lot of text with many, many documents and stuff, but that's, okay, I want to interpret what this specific sentence documents means, how to classify it, etc. So you could picture someone talking in a room to himself, and you overhear it, and there are many people like this, or he's talking a lot, and say, okay, let's try to understand him. Let's try to figure out what he's saying. But what's actually happening when we deal with text is not this single person that's just talking to himself, right? This is what's actually happening. So there is a social interaction, and we try to communicate our message and persuade people, make them do some stuff, like or change their beliefs or something. And not only that we communicate, like it's all very dynamic, right? Because this is a snapshot, and if you would take, you have taken a snapshot 10 minutes earlier, so this lady may not be crying, and the whole situation is different. So what I'm getting at, that language is used within a specific social context, and language is shaping this social, I would say, structure, and the social structure shapes the language again. So language is constantly changing, and the social structure constantly changing, and there are some, like, there is a relationship between the two. So if I go to the big vision of what I want to be doing, is that I want to start with language, find the social structure, see how it drives different actions, and then go back in the loop and see how we change the language and how we change the social structure. Okay, so this was a short introduction. Basically, we could apply this, I would call it vision or framework, to politics. We could track radical groups. We could take it to business settings of what's going on in sentiment, etc. And in this talk, I will talk specifically about politics, and I will give another short introduction about the specific case study. Okay. Yeah, I will just mention that last year at the ACL, we had a workshop at NLP on social dynamics, which I co-organized with Alice O, that was a visiting professor here. Okay. So our case study is to look at political data and see if we could understand what's going on. Now, the key maybe thing to remember, I don't know anything about political, American politics, okay? It's all going to be kind of unsupervised. Like, I do know a bit, and some people, political science scholars know a lot, so I could use their help in evaluation. But from my perspective, I come as if I don't know anything. Okay? And I want to discover partisanship, emerging burning issues, etc., maybe identify political spin, and eventually find the networks and influence networks. And we have some specific work that is currently being done about understanding connections between lobbyists and politicians and how they affect each other. Why politics? Because it's interesting and important, but and there is a lot of data. Politicians, they just, they release a lot, they talk a lot. But also as I said, the computer comes with no knowledge of politics, but me as someone that want to evaluate my work, we do know some stuff. We know the partisanship. We know the committee structure. We know what people vote for, etc. in roll call bills, etc. That's one thing. And B, the political system, maybe the fundamental thing about it is people communicate in order to make you vote for them, right? They want to be elected. So this persuasion and subtle communication thing that try to drive people to action is very obvious there. Okay. So there is not much prior work about computational methods for political data. There are a few more, but these are the main ones, and all very good and interesting. That's why I put it here. And interestingly enough, Justin Grimmer is a political scientist, no computer scientist, but his model is a very nice and sophisticated Bayesian model. Here, Wilkerson is a political scientist, and David Smith is from natural language processing. So it's a nice combination, like many works on these specific fields are done with political scientists. As I said, the general idea is to automatically identify coordinated campaigns or agenda settings and framing, etc. I will explain all these issues in a second. And yeah, so in some informal definitions, so you know what I'm talking about. So when I say topic ownership, I mean that some topics are associated with specific party or congressman, etc. For example, environmental issues are usually associated here in the US with the Democratic Party. Right? Agenda setting means that I try to promote my topics, the things I believe in, to set that this will be discussed, this is important. And framing is, it comes from psychology, but basically it's the way I use my words in order to create some impression. So for example, if we talk about tax on inheritance, so One party will use, like actually using words like death tax. You could guess which party. And the other party will use estate tax, right? Because, oh, he got an estate, we should tax him. And death tax is very negative, okay? Similarly, you could go with pro-life and pro-choice. But it's important to understand that framing is not only about fixed phrases, okay? Framing is the general way I refer to a topic. So if I talk about minimum wage or equal pay, so I could talk about civil rights and equality, etc. This is one frame. And I could talk about tax raises and job loss that it might incur. This is a completely different frame, okay? So I'll try to automatically understand and analyze this and the dynamics between this. Now, agenda shifting or spin is when I try to use all these like agenda setting and spin in order to make people, follow what I want them to follow. Okay, and so I guess I don't have to convince you that this is all very prominent in the political discourse. Okay, so this is how a public statement look like. Public state, we're going to work on public statement. I'll give more details about the data in a second. Basically, this is how a public statement look like. You don't have to read it all. We'll get to bits of that in later. This specifically was issued by John Boehner about, obviously, about the healthcare reform. It's all very anti. The words, like the highlighted part here, illustrate different topics / different frames, okay? So you could see in green I put healthcare and Medicare, Medicaid. In yellow it's job killing, 500 billion in tax hikes. And in this, I don't know what color to call it, like pinky orangey. It's different on my computer. It's like corruption and shady stuff, okay? And as you see, it's all in one statement. No. So basically we split it. If we see this, we split it to two words. Like in this example, when I highlighted, I didn't do that. But when we process the text, we do split the words by commas, by hyphens, etc. I'm not talking about this. I'm not looking at this as a phrase. Like the computer doesn't know it's a fixed phrase or should be looked at as a fixed phrase. We look at chunks of words. Okay. Yeah. Oh, that's a good thing. Like you should ask question in the middle, and if it's too long or that I don't know the answer, I will tell you that it's too long and I can't answer now. Okay. So, yeah. So we take the data, like there is Project Vote Smart that collects a lot of data about the political system. We have about 3,400 statements, about 50 million words. It's not like big data, but it's something that the average political science students will not be able to, to just sit during his PhD and annotate. Unique tokens is about 132,000, and it's by 645 representatives. And maybe the span is interesting. It's 4 full years from January of 2010 till the end of 2013. This is what the data look like if we count statements by party. And can someone guess what's happening here and here? Elections, right? So these are elections time, and you could also see, because there are some regulations of how many statements you could issue at election time, but you could also see that what happened in the elections of November 10, that the Democrats lost majority in the House, and you see it here. And again, the majority like shrank a bit, of the Republicans shrank a bit, and obviously we'll have to take care of that. If you actually look at the average statement per member, so Democrats are much more productive consistently. Okay, so when we're gonna model it, we'll have to normalize it by the number of seats. Some other trends that are important, and we'll have to get into the model. There is some weekly cycle. How many statements released in jail the week? So no one talks in the weekend, and people talk a lot on Tuesday and Wednesday. You could see the trend. There is also a yearly cycle here, which like less statements released in August recess, obviously, Thanksgiving week, and Christmas break. Okay, so our main tools that we're going to use to model and to try to capture these framing and agenda setting campaigns we're going to use topic models for pre-processing, and we're going to use autoregressive distributed lag models to find significant correlation between the time series, which we're going to interpret as definitely if there is a lag, as if there is some responsive pattern. Now, I'll be very careful about it, okay? Because what we're actually going to find is correlations, and there is no obvious causation, but I will also provide some qualitative analysis that would also suggest that there is some responsive pattern here between the parties. Okay, so topic models, and I'm just going to rush through it so you will understand what's actually happening, but on a very high level. So there are three main assumptions that you have to be aware of when you're talking about topic models. So each document is a mixture of topics, which means it's not, okay, this document is about sport and this document is about budget. I could talk about, transfers and the budget of some sport team. So the document could be about sports and budget and whatever. Each word could be basically I would call it generated from all possible topics. Obviously different probabilities. And a document is a bag of words, which means that I don't care, or I kind of ignore the grammatical structure of the document and of the sentences here, and each word is by itself. So in general, topic model, when I have these three assumptions, topic models, what it means is it's assuming that a set of documents was generated by a process in which for each document we have like a mixture of topic with some distribution. And for each topic, the generation process is as follows. Like I sample a topic from the topic distribution for a slot for a word, and then I sample a word from the distribution of topics of words, and I put in the word. I'm going to the next slot of the word, repeatedly till the document is generated. Obviously, if you follow this procedure, you'll get some gibberish. But a gibberish that reflects the assumptions and the distribution of topics in the corpus. Now, what we're doing actually in topic models is we're not doing this generative process. We assume this process and kind of reverse it for inference. So we actually have the set of documents, and we do inference. In this case, we use variational base in order to maximize the probability of having these documents generated. Okay, so it's all automatic. It's completely unsupervised, and what I give, like the input I basically give here is the set of documents, the number, some k, which is the number of topics that I want to get, which could be a wild guess that's supposed to be close enough, right? I don't know how many topics are there, so I could say k is 7,000. I could say 3, and the algorithm will work. But in order to get something coherent, I need the k to be relatively close in a way to what's actually happening. I could give some initial parameters for the distribution, but I'm not going to do it here because I don't know, as I said, I don't know anything about the topics in the political discourse, so I don't start with any initial weights for the topics. And I use the topic models. I'm going to skip that. And when I do this on the corpus, so I get like distribution of words per topic, how much likely each word to come from a specific topic. And if I look only at 7 topics here, and these 7 topics belong to 2 clusters, health cluster and the energy cluster. And if I look at the top 20 word in each topic, and again, this was automatically generated. So if you could look at 30 and 51, you could maybe see the difference. Can you see? Can you guess why these 2 topics were separated and they're not one topic? Like healthcare, bill, Obamacare, insurance, repeal, affordable. And can you read it? Like Medicare, seniors program, social, Medicaid. Yeah, so because we have some knowledge of the political system, we see these words and I can say, oh, this looks like more Republican and this looks like Democrat. Okay? But again, this is not real evaluation. We'll see some other things. I could also, because we know the system, so I could say that words like repeal and that using the term Obamacare instead of Medicaid, like kind of suggests that. But again, this like classification or this separation between the words here, the top words, like this is done by in a completely unsupervised way. Yeah.
The clusters and the labels, were those your labeling?
Okay. So great question. So the labels are two people labeled it independently and kind of agreed on the labels. The clusters, we actually did these clusters, but we also try to cluster automatically. And you could see again by this word that it will cluster together pretty nicely, right? But this table specifically, we added the cluster and the label just to make it easier to, yes?
How many topics were you looking for here?
Okay. So in our settings, and I was about to get to it soon, we choose k equals 100. And eventually in the work, and I will tell you a bit about that later, we focused on 14 topics. 14 of the 100. Like we ran the LDA with 100, and when we did further analysis, we focused on the 14 most prevalent topics. And yeah. Mm-hmm.
Are not mixing. I don't know what.
No, okay. So yeah, that's a great point. Yeah. So the mixture thing is about the documents. We say that a document is generated by the mixture of topic. These are not the document. These are the topics. And B, you could see that there are, I don't know if you could see specific here that are mixing, but you probably will be able to see like some words that appear both here and here.
Between health and energy.
Yeah, so these topics do not mix because these are the topics that the algorithm separated. When I use these topics, both of these topics to generate a document, or when I actually look at a specific document, they will be mixing. Also, like I only have here the top 20 words for each topic. If you look at all the topics, obviously, that's part of the assumptions of the model. So words are shared with different probabilities.
Let me rephrase the question. It seems to me like among the 100 topics, you have these meta topics, like health, energy, and others. That between those meta topics, you don't see mixing. A typical document will not be mixing among those.
That's a very strong assumption. Well, it's I do not agree. I do not agree, but it's, and what I'm saying is it doesn't really matter because what we actually care is about the documents themselves. And yeah, possibly there will be document that will have very low probability of one of the topics, like we will have like 2 words generated from this topic, which is basically reflects what you're saying. And I think I have one slide that shows the topic, the average topic distribution in documents, so you'll see what I'm talking about. And if not, ask me later, but I think it will be in a few slides. Yes?
So maybe this is where you're going, and if so, tell me to just shut up. But your statement that, this sounds like a Republican set of words and this sounds like a Democratic one suggests to me that you could imagine the topic models coming up with 2 distinct topics for what are in effect the same subject.
Right.
It's just how do Republicans talk about
Exactly.
it.
That's exactly what I'm saying.
Okay.
Yes. And I'll give more evidence to that. Yeah, this is just, a very intuitive way to look at it. And if I'm just, throwing some more intuition about it, so when I actually prepared the slide about a month ago, it was just after the State of the Union, and this was the title, the title at the NPR website, which is exactly the 2 Republican topics here, 30 and 38. Like 38 is about the Keystone XL. What's nice about this is that this data is from 2010 till the end of 2013, and this is from February 2015. Yes?
So there's a perfect example of mixing across the clusters.
Yeah, it's as I said, like I find it hard to just find it now on the spot, but obviously, definitely, as more, if you add more words to what I present here, you'll get it more and more mixed. Yeah. Okay. So now we're going to assign topic to statement. And here is maybe an answer to your question. So when I now that I have the topic distribution over words, I could go back to the documents and say, okay, so let's find what topics generated this document. And I do that by, now I have the words, I look at the word and say, okay, this is most likely to be generated from this topic. This is most likely to be generated from that topic, etc. So if I look at all the 100 topics, so what I get is that between 5, let's say, topics generate a major part of the document, and then I have kind of a long tail here, which, some of the 100 topics generate like 1 or 2 words, and as the document goes longer, like you get more chances of seeing this tail. But what it is, and this is, this is part of the side. This is a side effect of the topic model, of the assumptions in the model. But what it basically suggests is we definitely don't care about this, and I don't know if we care about this, but we do care about this. So in a greedy manner, what we did is say, okay, let's check how many for each specific document, how many topics and which topics cover the top, as I said, in greedy manner. The top 25% of the document, and say, okay, this document is about these topics, and the rest of the document are actually generated from these specific topics. So in this way, we kind of prune this thing, but we still keep the mixed membership assumption of the topic models. Okay? Because as you said, it's not very likely that every document will be generated from the 100 topics. Okay, so yeah, this is what I say about how we change the topic ownership. And what we get eventually is that each document is generated from between 2 to 6 topics. Yes?
Another way to get that effect would just be to reduce the number of topics that you run the model with. So
right.
Why do you run with a large number of
right,
as opposed to just running
yeah,
with
so yeah, that's a good question. So we tried some other numbers, not only 100. We tried like 200, 500, 1,000, and we also tried 30 and 50 and 20. And
if you want 14 topics, you could run with 14.
Right. I didn't know I want 14 topics. I chose these 14s because they were more prominent, and after assigning these 14 topics, they dominate many of the statements, or the big chunk of the statement. So I didn't know much. So I wanted to have a guess that is higher than what we actually have, but not too high. And when my guess was too low, so I got topics mixed together. And again, since this is an unsupervised method, so the algorithm will, converge and will output something for each k that I give it. Yeah, I could give k equals 1 or 2 or 3, and I'll have this separation to 1 or 2 or 3 topics. So this is kind of a wild guess, as I said. So 100 seems reasonable, and we verified it by the annotation. Two people annotated the top topics to see if it's coherent or not. And indeed, with the 100 topics, some topics were completely incoherent, probably the tail topics. Some were very coherent, and some were about the political process and boilerplates and some formal language that doesn't give you much information about the topic. But if you're interested in that, you could say, okay, this is like a way of reporting about committee work and stuff. Okay, this is a heat map of the co-occurrence of topics within statements, within specific statements. And yeah, these are the 14 topics, and the 14 topics belong to 4 clusters: health, energy, security, and budget or economy. The numbers here are normalized PMI because you want to account for topics with more that appear more in more documents, etc. And what you could essentially see here is the block structure along the diagonal, which means that topics from the same cluster tend to appear together, which is, again, this is a side effect of the model, right? Because the word health actually belongs to any of the health topics, etc. So the model can get mixed on that when I reassign the words, the topics to the document. And then you could get the impression of what's going on with what. But more interesting than that, what happens if I break it? This is what I showed you before. What I break it, let's look only at Republican statement, and let's look only at Democratic statements. right? So you still, the diagonal thing with the blocks still appears, which is again to be expected. But you see some differences between how the different parties bundle topics together, okay? So maybe the something that jumps in your eyes is how Democrats and Republicans mix or don't mix health and energy topics, right? But there are more subtleties here, and we'll get to some other numbers soon. Okay, and this is when I look at the data as a whole, right? I don't have any temporal thing here. I just have, okay, I know which statements were generated by Democrats, which statements were released by Democrats and Republicans. Okay, let's talk now about topic ownership, okay? Because in order to try to model the framing and what's going on and see campaigning over time, I need to first do some topic ownership modeling. So this is what happens, okay, now I'm focusing here. Okay, just ignore the rest. If I check how many statements were issued by each party on each topic. And again, the topics are assigned automatically. I didn't know that in advance. I use the topic models for that. And what I see here is if I look at the cluster level, for example, it seems that Republicans are controlling the discourse about health. Okay? I don't know if it makes sense or not. What I want to show here is that if I look not at the cluster level, but on specific topics, again, topics that I learned from the algorithm, right? I didn't come with my knowledge of politics, so I get a very different picture, because Democrats control topic 30, okay, and like really control topic 30, and the Republicans there control topic 30, and Democrats control topic 51 and 80. You see, if I just count statements. Again, no time aspect here, temporal aspect here. So again, this gives us an indication that the breakout of topics by the LDA, we use LDA if I didn't mention that. So that's an assumption of what type of distribution I use for topics in the corpus. So the topic model algorithm kind of makes sense here. But now let's introduce a temporal thing, and let's look what's happening if I break it into weeks, okay? Because you could say that, okay, Republicans like control this topic because in one specific week they issued like 1,000 statements, and that's why it's so high. But if I look at what's happening all through the year or the 4 years, the difference is not so obvious between the parties. So if I only look at what's happening, like I count how many weeks, like per week, which party issued more statement, so I get this, okay? For topic 30, 154 for Republicans, 46 for Democrats. And you see this is kind of consistent with what I see here. But I want to introduce something else. Let's see not only how, like which topic and which party controls the discourse on what topic in a specific week. Let's see if it's significant, okay? Because the fact that one party issued 3 statements in a week on a topic and the other party issued 2 statements, you can't really say that one party controls the discourse. So this is what I get after I do some significance tests. And I say, okay, let's say that there is some Bernoulli process in which parties issued statements. And another hypothesis is that it works like the both parties you have the same parameters, okay? So I expect sort of the same number of statements per topic per week. And I count only the weeks in which I find significant difference between the parties. So again, here the Republicans control like about 3 times more weeks than the Democrats. But if I look at like significant control, I get a much stronger picture. Okay, and this is also to be expected because people don't talk about parties don't talk about all the topics every week. Definitely not campaigning about these topics.
How does it vary if, P is obviously less than 5%?
Yeah, that's P is.
Down from us, but like, if I said 10%, does the 2 versus 79?
I didn't check 10%. I did check 0.005, and you get sort of the same thing, but much lower numbers for both sides, obviously.
But the ratios are similar?
Sort of similar, yeah. yeah, what's interesting here is that sometimes it flips. Like if you look at here, if you look at the topic 38, so if you just count statements, it's 255 versus 128. If you look at what happens in weeks, so suddenly Democrats control the discourse more weeks. If you, again, take significance into account, so again, Republicans control more weeks, not much more. But it gives you the hint of how the process looks like when people try to campaign against each other. Okay, so we have, just to summarize what we're up to this point, we have no knowledge of the topics and the political system, and we automatically discover the topics and the topics per statements, and it looks correct. Okay, it looks correct if you just look at statements or topics with the eyes, but it also looks that it finds some trends, like partisan trends, that make you think, yeah, this is correct. And we didn't really introduce any temporal time except in the past, in the last, what we checked it by the week. But now what we're going to do is introduce a temporal model and try to correlate time series of the parties. So, yeah, so what I actually have is, if I have statements and I know which party issued the statement and I know the timestamp of the statement, okay, so I could have a time series for each topic, I could have time series for each party. What I'm going to be doing is I'm going to try and correlate this time series, and every pair of time series I correlate, it's always from each time series from different party. Yeah, that's what you need to remember. So I always try to correlate the time series from different party and see if I find significant correlation. But I'm gonna address auto-regression and some other stuff, and I will introduce lags here because sometimes I will see that the correlation that is achieved with a day, 2 days, or more lags. Okay, so I would interpret that as some response, right? I'm talking about this topic now, and the other party is responding 1 day, 2 days later with some high peak of something. Now, this is, I have to be careful about this, but just keep that in mind. Okay, so I just remind you that there are some seasonal effects here by the week and by day of week and week in the year. Another thing I have to do is detrending, because if I try to find correlation with lags and there is some trend in the data, it's hard to see here, but there is trend based on the number of seats and trend based on terms, etc. So obviously I will get significant correlation, but this is just because there is a trend. So I have to detrend it, and I use first difference detrending. And the model I'm using, and this is a bit, some simplification of it. So YT is the values of one time series of one party, okay? X is a time series of the other party, sometimes with lag, sometimes with lag 0, okay? The Y is here, the term here controls the auto-regressive thing, because maybe at time t, some party, like the Democrats talk at time t a lot about some specific topic, not because it's a response to anything the other party said, because they always talk about it, because they talked about it yesterday, so they also talk about it today, right? So I do have some auto-regressive component here, and I do account for seasonality here, which will be a matrix like the identity matrix for each, like for day of the year, day of the week, and week in the year, in order to overcome this seasonality effect, which is obviously circular here. Okay, yeah, so in pre-processing, we created the time series, basically. And in the regression model, we have the lag component, and we have the control for seasonality and for autocorrelation or autoregression. And what we're looking for is response patterns, and I put it in parentheses again, because this is actually correlation, so it's hard to talk about the causation here. And this is what I find. This is a summary. We find, oh, one more thing that I have to say. We try, because we have 14 topics and we have different lags, so we actually try a lot of pairs. So obviously some of them will get correlated by chance. So we do correction. We use the Bonifroni correction, which is essentially what it's doing is to say that in order to declare significance, the p-value drops a lot depending on the number of series you try to fit. And this is what we get for lags 0, 1, and 2. And this is disappointing, or I was disappointed at first glance, but actually it's interesting what's going on here. So you see that most of the significant, and when I say significant correlation, I mean that the coefficient of the x is significant, right? The contribution of the x term is significant. So yeah, so most of the correlations are in lag 0, and most of them are intra-cluster between topics that are within the same cluster, and some other correlations are between topics from different clusters, which could show, both of them could actually show some framing techniques, like how do I frame, how do I refer to a topic? You talk about this, so I will talk either about this specific topic, but with different terms, or with my way of talking about it. So as you say, it's a mixture of what I say about these specific topics and different perspective on how it will affect the economy, for example. We find very small number of correlations, like significant correlations with lags 1 and 0. And this could be due to two major reasons. One is that my timestamps are I could also say that there is no responsive pattern at all, right? Or almost non-responsive pattern, so that's why I find it was like 0. But if I still believe that there is some responsive pattern, I could say two things. Either that my timestamps, the granularity of the timestamps, doing it per day is not good enough, and maybe I should check by the hour. But I can't do that because I do have sometimes times like hourly timestamps, but they are noisy and inaccurate and missing a lot of the times. And the other explanation could be, okay, maybe they just refer or respond to an external event, to an external event. So they respond to the external event in the same day, but again, each party responds to it in a slightly different way, with a different mixture of topics. Again, this is what we said is a framing thing, right? Each party tries to frame it in different terms and try to convince you, hey, look at that, here is a bird, or look at that, like it will cause you to lose your job, instead of cause you to have, I don't know, equal treatment at the doctor. Yes?
Just a clarification. When you say lag equals 1, is that 1 day or 1 week?
1 day. Yeah, one day. Yeah. I didn't mention it because when I did the significance before, I was talking about weeks. Here is the lag is 1 day.
In your little footnotes there, you talk about weeks.
Oh yeah. So that's a mistake because we also did that for weeks and months. And yeah, that's we got some similar trends, not as obvious.
Days.
These are days. These are definitely days. I needed to fix that. Yeah. Thanks. Yeah, you're definitely right. Okay. Yeah, just one more figure here. This is how many correlations I found for each lag. And this is the number of correlations I find per lag. It's hard to see here the numbers, but this is the number of lags. If I don't do the corrections and I don't account for seasonality, and you could see that I have the weekly, what I actually see here is the weekly trend. Okay, so just to convince you that the corrections are crucial in that case. Yeah, and if I want to just do some very quick qualitative examination of what's going on here. So I go back to this statement by Boehner, and these are the time series again per day for topic 30, and I think that's for topic 80, but I don't remember. But one of the topics that were found correlated with it. And let's look at this peak, which is where we sampled this. Like I didn't specifically look for this statement. We just sampled statements from from a few days before, a few days after this peak, and this is one of them. But this is very representative in a sense that, okay, this is correlation with lag 0, but it specifically refers to a statement by the other party. So here it says this statement by Boehner was released. Boehner released the following statement today on President Obama's healthcare speech in St. Louis. Okay, now when I sampled what happens in this peak, like many, and I read many statements from the Republican Party, majority of them refers to this speech by Obama, to this speech statement by Obama. If I look at what's going on the Democrat statements, some of them referred to this specific statement by Obama, but much lower numbers, or much lower ratio, I should say, because the numbers are lower anyways. So this gives you another indication, qualitative though, that there is some responsive pattern going on. Yes?
Well, I think it highlights the fact that not all statements are equal, right? So when you look for correlation, you kind of treat all samples as if they're the same or have similar weight. But some statements, I guess, they hit the social media and everybody hear about them and it's on the front page of newspapers. Whereas some of them, no one ever, except for the people who had to happen to sit and hear it.
Yeah, that's
talking. So when you look for correlation, it kind of so you have very few samples that are responsible, like this. I don't know, speech by Obama that is responsible for a huge part of the responses.
So you're right. That's why that's a nice example. But in general, you're right. But you also have to remember that we're talking here about public statement. That is something almost it's like it is basically addressed to the public, but the people who read it are journalists and stuff. This is basically addressed to your peers and to journalists, and supposed to, as you said, maybe go viral, or you'll see what's important or what's not. But within this closed ecosystem of political statement, we have no idea or no way to know in advance which one will go viral, will affect the media.
Well, you can look at the speaker. So
yes and no. No, that's true. So that's in that case you could look at the speaker. But when you find the correlation over time, a significant correlation, not all peaks here are triggered by Obama. In this specific case, maybe because it was Obama, so we see the specific reference, and if it was, if it was response to some, I don't know, law that passed or something, we'll see the statements, we'll see the peak, but we'll not see the very explicit reference. Okay, but one other thing, do I have more time? Yeah, do I have 5 more minutes? What's it? Yeah, okay. So one interesting thing that this triggers is that it looks like Republicans are much more disciplined as a party than the Democrats. Now, in general, this is a known thing, but it's known about how they vote about bills. There are many works about how disciplined are Republicans in voting, within the party lines, and the Democrats are more free, I would say, to vote to their likings. And there are a lot of work in political science about that, again, on voting on bills. But there is not any work, actually, about how disciplined they are in following party lines in talking points. Okay? If there is specific, I would call it campaigns of, okay, now we're all going to talk about this topic and mention A, B, and C. So I talked to a few political scientists, and they all said, yeah, this makes sense, and we know that, but we don't really know that. We never gave any quantitative analysis or account for that. So what I'll just describe here, and I'll end it by this, is I say, okay, we don't have the talking points, right? Because the talking points are distributed to party members. I don't get the talking points, so I can't see if they actually repeat the talking points in their statements. But what I can see is look at Ngrams and see how frequent Ngrams are shared between parties and within the party in statements of a given day, for example, or in a given topic. And this is interesting because if I look at how many, like who has more shared Ngrams on specific topics in general, so what I get is that Republicans has much more shared Ngrams on all topics in general, averaged by topics per party, etc. If I break it to Democratic topics and to Republican topics, which is this graph and this graph, so obviously within each party controls the Ngram, which in all length of Ngrams, yeah, that's like I tried from 2 to 14, in all length of Ngrams, like use similar Ngrams in all Ngrams on the topics that they dominant. But what's interesting here is if to look at the difference. And again, if you see the difference between here and here, why the Republicans, for example, use here slightly more than 30 shared Ngrams, and the Republicans and the Democrats on the same topic use much more. But so it would basically, like one way to interpret it is that some Ngrams are inherent to the topic. So that's why when I refer to this topic, like Affordable Care Act, so I will use this Ngram. But what's interesting here is that the gap is bigger when you talk about the gap between the parties is bigger in the Republican dominant topics than in the Democrats, which means, again, that Republicans are probably much more disciplined in using the same language, which is a proxy to talking points, than the Democrats. I don't know if it's good or bad. Like it might be good politically or not. Like, but this is something, as I said, that political scientists didn't know before, but they got the feeling, and again, using topic models with all these settings, so we get a very clear picture of what's going on here. Yeah, so this is a summary of the talk. So I use topic model. Everything is unsupervised. I don't know anything about the political system. I automatically discover the topics, and it makes sense. I use the topics to create time series, and I find correlations within the time series, again, accounting for seasonality, trends, etc. And I find some interesting cases when I clearly see responsive patterns between the parties on different topics, which, again, could be interpreted as different framing campaigns and campaigns for agenda setting. I didn't talk at all about sentiment, but we have some complement part that does sentiments, but it does appear here, but I'm going to skip it. And basically, that's it. Yeah. Yeah.
What about the problem of prediction? Presumably with the definition of the topic is distribution of words, you can take a new statement, predict what is the most likely topic, predict if the person most likely to be Republican or Democrat. Does it become a prediction for new data, unseen data?
Okay, so there are works, not on public statements, but on blogs usually. And there is also a lot of criticism about these works that tries to automatically identify the political orientation of the writer. So it's done, and it's apparently, I don't know if it's done with topic models, but it's been done, and the results are quite nice with one, I would say, one refrain or one asterisk, that the people that do this type of works, they do it usually in a supervised way, or at least have some gold standard. And in order to achieve this gold standard, you need the people to declare what their political orientation, and then your whole data set is a bit biased, because someone who declares himself, I'm an avid Democrat, so yeah, so his writing will reflect that more than like if I don't know what's your political orientation, but if you write about politics without declaring that. But in general, it can be done, and it's like looked as classification task, and it's done relatively well, given that the data set that is used for that is a bit biased. I would also say that I just reviewed a paper that tries to do that without this, without this gold standard, and the results are pretty bad.
sort of prediction within your own task. Like predicting, given that I've observed this time series of topics, can I predict next week, you know, what topics will be talked about from Democrats and Republicans?
Okay, so that's a cheap trick. Why is it a cheap trick? Because this is a nice way to turn this work into a prediction work. Now I know it happens, right? Because I did find correlation, so I know if I did find the correlation and I find it over time, so I could say, okay, let's just cut the time series and say, oh, I learned the first, few weeks, and I predict what's happening the next week. So I kind of know the answer. So yeah, you could do that, and it will work. And in a way,
yeah, but I mean, you could it's not just a cheap trick when you a lot of times when you use so I'm going to cross-validate. I'm going to do it's not just it. Yeah, I agree that if you train it exactly on week 52 to week 53, sure, but just more
I didn't try this, but it will probably. It's easy to say that it will probably work, right? Because I didn't try that.
Yeah.
It's famous last words for projects that will go on for years. Yeah, but yeah, that's another look at that. Yes.
But I guess just one way that other people have thought about these things are looking for certain features. How much does the addition of that feature improve your accuracy? How
Right,
you defined it, right?
So the one thing we did sort of in that line is to find what features improve the correlation and discard them. For example, the seasonality. For example, the autoregression, the autocorrelations. In order to not to use the data from last week to predict this week in too obvious way. Yeah.
Is there any variant of these methods that could automatically discover some of the structure within the set of topics that you have? So I mean, you did the clustering of topics, but also this Democrat-Republican, it seems like what's really happening there is that your topic space is two-dimensional. There's the subject matter and then another bit, which is which party is talking about it.
No, I'm sorry. Completely.
And one can wonder whether somehow that can be automatically discovered and that the algorithm will produce, this is a topic, the sort of two columns. This is the words that correspond to Democrats talking about this topic, and this is the words that correspond to Republicans talking about the same topic.
Okay, so I could argue both ways. Okay, so I'll start with the good answer, which is this is actually what we did, and this is how the topics within the cluster got broken into two topics. But this is very soft, and this happens a lot with language, right? I can't really give you 100% proof for that, right? Because it's language and it's flexible, and maybe there are really two different topics. So another way to do that, but it might, in order to maybe prove that this is actually what's going on here, will be by creating an annotated gold star, have many people just annotate the documents and say, okay, yeah, this is on exactly the same topic. But again, you go into all this consideration, what, I would call it philosophical, debate, what is a topic? If I use different framing for the same topic, is it the same topic or two different topics? It's hard to give an exact answer for that. Okay.